Okay. Okay, so this is only my fourth time recording it, so. Gee. Okay, hey. Staying positive, y'all. Introduction to Evolution, Part A. Let's see if I can do this. Alright, so I split this into two parts. Evolution A, Evolution B. Today we're going to talk in Evolution A about the history of people's ideas about the universe and Earth. And in Evolution Part B, we'll focus more on life, and that's where we'll learn about Darwin. All right, so evolution has three different definitions. So just the common usage is just change, the evolution of dance, the evolution of technology. It just means change. In this class, we're going to focus on the second definition, evolution as a theory in biology. So here it's defined as descent with modification from a common ancestor. I'll define it a couple different ways as we progress over the next couple of lectures, but the idea here is that animals or organisms change in time. And I'll come back to it. We'll cover that in a lot more detail. And then the third way that evolution is often used is kind of in the sense of a worldview or philosophy. So evolution is used as an explanation that the universe changes, Earth changes, organisms change due to natural processes entirely. There is no God guiding this. There is no objective morality. Spirituality is just made up by humans. So it's more of a view that takes stake in not just how animals change, but why. And the why is because of the laws of nature and of the laws of physics. It has nothing to do with God or gods. So we'll come back to evolution as a philosophy a little bit later on. All right, so let's begin by talking about how human concepts of the universe have changed over time. And as you can see here, it's split into four models, beginning with the most ancient, the three-tiered universe model, and working our way up to the current model, the Big Bang. All right, so let's talk about each in turn. All right, so in ancient times, people just didn't have science, man. So they viewed the world according to just what they observed. And so if you're standing on the surface of the Earth and you look out at the horizon in all directions, it just seems flat, right? The rise of flat Earth movement today is like kind of a well, I won't talk about that. Okay, so people thought that or when they looked out at the universe, they said, "Look, it seems like the sun rises in the east and sets in the west and moves across the heavens." And so the sun must rise on one side of the earth and set on the other, and then maybe it's reborn or it goes under the earth or whatever. There are different ideas about this. But the point is, the sun would be relatively small, and the moon would be relatively small, and they would move across the heavens. And people also said, look, the earth doesn't seem to move, right? So the earth is maybe standing on pillars, or it's on the back of a turtle, or whatever. Lots of different ideas on that, too. And they also said, look, when it rains, we know what water is, and why would we get water falling from the sky? Well, there must be a source of water up above. So the idea here is that the air above our heads, the heavens above us, are empty space that are holding back waters above. So we're kind of like in a little snow globe. And so when it rains, this water is leaking through windows or holes in this firmament above us. This firmament, as you can see in the picture, normally keeps these waters away. But when God or gods decides it's going to rain, they open up some of these windows in the firmament. The rain falls down or the snow falls down and falls on the land below. And so this is a very, logical model. If you're just looking out and you don't have science, you don't have telescopes, if you're just, observing what you see, this model makes a lot of sense. All right, but of course, over time, with the rise of mathematics and eventually technology, humans started to figure out that this isn't how the universe is orchestrated. And so the first model is geocentrism, the idea that the Earth is the center of the universe. So again, this goes back to this idea that it doesn't seem like the Earth is moving. It seems like the sun is moving around the Earth. And so the Greeks were kind of the first to propose this in the 3rd and 4th century BC. And they said, look, the Earth is static, and the sun and the moon and the stars and the planets all move around the Earth. Right? And so the Earth is a sphere, and everything else in the universe is rotating around us from our central viewpoint. So this makes a lot of sense too. It certainly seems like the Earth is the center of the universe. And the Greeks were math nerds, and they also said, you know what? Circles are perfect, spheres are perfect shapes, and so the orbits of the sun and the moon and the stars are perfect circles, and the sun, the moon, the planets, etc. They're all perfect spheres, and so they had this idea that there's this perfect spiritual world beyond Earth, and that the Earth and everything on it is maybe physical and can be imperfect, can be damaged and maybe can change slowly over time, but everything beyond Earth is perfect and was created by God or gods. And so Aristotle promoted this, and this was the prevailing view for millennia. And then in the 16th century, Copernicus, who was a Catholic priest and astronomer, said, you know what, I don't think this model is right. And the reason he said that was because he was pointing his telescopes out into the night sky and tracking using math the movement of Earth and Moon and Sun and stars and planets. And so he wrote his ideas in a book that was published in 1543 that was subsequently published after he died. And in this, he argued for heliocentrism. This is the idea that the Earth is not the center of the universe, but rather the sun is. And so the Earth is actually rotating around the sun. The sun doesn't move, the Earth does. So it was basically a shift in reference. And Copernicus didn't make a lot of waves, probably primarily because he was dead. But Galileo was he was an Italian astronomer, and he read Copernicus's book and agreed with it. And he used even better telescope technology to kind of confirm or lend support to Copernicus's ideas. Galileo got in a lot of trouble for this. The church and just general people didn't really appreciate his ideas. It's kind of humbling to replace the center of the universe, to change it from the Earth to the sun. And so people didn't really like that, and they thought it went against how they were reading the Bible. And so there was a big Galileo was put on trial. I could spend a lot of time talking about that, but I won't. The idea is Galileo was basically persecuted for his ideas because they went against the status quo. But over time, Galileo's ideas were supported by subsequent astronomers, and in time, heliocentrism became the accepted viewpoint. Also insulting an insulting aspect of this model was the idea that, the orbits are not perfect circles, they're kind of elliptical. And when Galileo looked at the moon, he saw all these craters, and so the moon isn't this perfect sphere, it's pockmarked and scarred. And this also threatened the idea of a perfect universe outside of the Earth. All right, so in the 19th century, an American astronomer by the name of Edwin Hubble took even better telescopes and pointed them towards the stars and did some math again. I hope you're seeing a theme here, math and telescopes. And he said, oh, and by the way, you've heard of Hubble because they named a really good telescope that was launched into orbit after him about 30 years ago or so, 20 years ago, I don't know, a while ago. And what he did was he looked at these stars and he looked at the wavelengths of light coming from these stars. And he said, when he looked at these wavelengths, he realized that the wavelengths were stretched out. So in other words, the wavelengths of the stars were all shifted towards the red end of the visible spectrum. And he said, you know what, this is because the stars and these distant galaxies are moving away from us. As they move away from us, those wavelengths get stretched out, as you can see in the image on the lower left. And he said if the stars in these distant galaxies were moving towards us, we would expect the wavelengths of light to be squished. So the long stretched out wavelengths, this is called redshift, and the squished wavelengths is called blue shift. And what's important here is Hubble, everywhere he looked, he saw that these distant stars were displaying redshift. And so the implication of this is that all the stars and all the distant galaxies around us, they're all moving away from us. And they're not just moving away from us, they're moving away from each other. And so Hubble said, you know what? If all of these galaxies are moving away from us, it means tomorrow they're going to be farther away. So he said, the universe is, this means that the universe is expanding. And if you play the tape backwards, it means that yesterday all these stars and galaxies were closer together. And the day before that, they were closer together, and so on and so forth. So you can do math, and you can say, a long time ago, all of the stars and galaxies were right on top of each other. So in other words, the universe originated in a point. And this is the Big Bang. The Big Bang was when everything in the universe was kind of compact, and you could have held the universe in the palm of your hand. And since that time, everything has been moving away from everything else. So the universe begins at a specific point in time and then subsequently expands. That's the basics of the Big Bang model. And using math, they were able to figure out that this happened about 13.7 or 13.8 billion years ago. So it places it starts the clock on the age of the universe at almost 14 billion years ago. So when the Big Bang happened, the universe began. We don't know how. It doesn't postulate where it came from. It just says, look, the mathematical models go back almost 14 billion years to a universe that in the beginning was almost pure energy. And then some of that energy got converted to matter. The matter was initially just subatomic particles, like electrons, and then protons and neutrons formed eventually. And what would you expect the first elements to be? Well, the simplest. So if you get a proton and then it catches an electron to go and orbit around it, then you've got hydrogen. So it postulates that the first element to form was hydrogen. And that makes a lot of sense because this hydrogen would then come together, pile up together in big clouds of gas, which is basically what stars are. And so in stars, this hydrogen starts to get squished together by gravity and it forms helium. And when the hydrogen gets converted to helium, the stars light up and they start producing light and heat. So this explains where stars come from. And it says that stars are born and that stars can also die. So stars burn the hydrogen, convert it to helium, and over time they build the larger elements like oxygen and nitrogen and carbon and so on. And so a long time ago, a star or stars formed these larger elements, and then those stars died, and when these stars died, they blew up or created supernovas. And that carbon and hydrogen and etc. blew out into space and formed our solar system. So the hydrogen and some of the helium maybe formed our sun, and then our sun kind of sorted these larger elements to create the various planets of our solar system. And so our solar system formed about 4.5 billion years ago. All right, human ideas about the Earth. So 3 models: young linear, old cyclical, and old evolving models, again going from the most ancient to the modern one. So the young linear model, which I've confusingly called just biblical chronologies on this slide, my bad, says that around the, 15th, 16th, 17th century, people said, hey, how old is the Earth? Well, they didn't really have a good way of figuring that out. They didn't have a good way of figuring out how old it was. And so they said, let's just look at the Bible. So the Bible talks about Adam as the first man, and we know that Jesus was born around between 2 and 4 BC. And so if we add up all of the lifespans in the Old Testament and those long genealogies in Genesis and other places, that we can calculate when God made Adam, and we know God made Adam on day 6. So basically we can use the Bible to figure out how old the Earth is. And so there were lots of different biblical chronologists, people that used the Bible to calculate the age of the Earth. But James Ussher is perhaps the most famous. So in 1650, he basically said, look, I did the math, and the Earth is about 6,000 years old. In fact, he got real precise. He said God created the universe, the Earth, and life, or at least he created the Earth, on October 23rd, 4004 BC. So this meant that the earth was young and basically hasn't changed a lot since when God originally created it. And then in the 17th and 18th centuries, people were starting to realize that there's lots of rock layers and fossils below our feet. So catastrophism was an attempt to kind of marry the Genesis account with this expanded knowledge base that science was providing. And so Cuvier was this Frenchman, and he came up with catastrophism. And he said, look, we get all these layers of rocks and fossils. How do they get there? Right? And how come we see like weird fish in the lower layers and we see mammals at the top and humans at the very top? And he said, well, God must have created over process. So God created stuff, and then he would send a flood or some sort of disaster that would kill these things. And these disasters or catastrophes would kill a lot of the animals and plants that were in a certain area, and then they would die and they'd be fossilized and it would create a layer. And then God would maybe create new organisms or organisms would move into these destroyed areas, and then eventually he would destroy them too. And that would create another layer of rocks and fossils. So he said there's periodic natural disasters that destroy God's creation. This is just how God created. And Cuvier was basically saying, look, we got to figure out a way to adapt the new evidence that we know about rock layers and fossil layers with the Bible. And an implication of this is that the history of the earth is kind of violent, and there's been lots of change, and it's taken a long time to occur. And then those ideas were changed by Lyell and others. So in the 19th century, Lyell published a book where he said the present is the key to the past. And this just means that we can study the earth as it works today, and we can extrapolate back into the past. So if we see that a layer of rock is forming at a rate of, let's just make something up and say a quarter of an inch per century, and if this layer is an inch thick, then it would take 4 centuries for that inch layer rock to form. And so this layer is 100 years old. And if we add up all these different layers, we can calculate that Earth is really old and that it formed and changed really slowly at kind of a constant rate of speed. So there weren't catastrophes that were causing these rock layers and fossils, but just simple processes that we see in action around us today. And so if you add up the ages of these layers, you can come up with lots of different estimates. But the point is, the Earth is millions of years old, so even older than Cuvier would have suggested, in that the Earth kind of gradually and steadily changes in time. And so this is the prevailing view of our modern viewpoint. Ooh, that's the end of part 1.